Welcome to the Martin Bailey Photography Blogcast. It's December 15, 2015, and this is episode 501. In the age of digital, with the histogram at our fingertips, the light meter is in many situations no longer as necessary as it was years ago, but there are a number of reasons why I continue to use one. I recently added another reason by creating a camera profile for my Sekonic L-758D light meter, which increases its usefulness even further. So today, I'm going to walk you through that process and why I find having a camera-specific profile in my light meter useful. Before I go into details on the process for creating the profile, I'll explain what this enables me to do so that you don't continue to wonder what this is all about. First of all, I'm using the Sekonic L-758D digital master light meter. In the States, this is the L-758DR, which I believe has some extra pocket wizard features, but they're basically the same meter otherwise. I'm sharing quite a few photos today, and because Apple still haven't really fixed the problems with the enhanced podcast on the iPhone, if you would like to follow along, visit the blog post if you're not already there, which you can find at mbp.ac/501, and click on the images to view them larger so that you can see the details that I'm talking about. So in this first image of the L758D digital master light meter, if you take a really close look, you'll be able to see a scale between the bottom line of numbers that reads from -7 to +7, and then there are 5 carets that indicate meter readings. But between those two things, there's a line of 23 upward pointing triangles, and then there's one more to the right and a second a little further away on the far left. This line of dots represents the dynamic range of my camera and is there because of the profiling process that I carried out a few weeks ago and that I'm going to walk you through today. How cool is that though, right? I can actually see the dynamic range of my camera right there on the meter. What this means is that in the field I can take meter readings from the scene and decide how to approach the exposure based on how high I take my highlights, and more importantly, how dark I'm prepared to let my shadow areas fall. Now, yes, of course, I can do all of this with the histogram, but being able to measure and analyze this data as I shoot is an incredibly valuable tool for understanding exposure, especially when you start to take a look at images and map the tones in your images to understand why certain situations are possible and when others simply wouldn't work. Also, quite often in my case, and maybe yours too, being able to look at the various exposure readings from a scene is an invaluable tool in the teaching environment. I walk people through exposure during workshops, and although this often works for Canon users, explaining with a camera is not as useful as being able to actually show the readings right there on the meter. The meter is much more objective and kind of removes the ambiguity that a camera can often introduce if the student isn't familiar with my camera system. I do use a meter practically in various situations too, both in the field and when I'm setting up studio lights. And the Sekonic L758D, or the L758DR in the States, as I say, has some incredibly powerful features for measuring and comparing studio lights and ambient light conditions, etc. But we aren't going to get into that today. I've been using a meter for more than 15 years now, and I've always found them to be a very valuable tool to help me learn and teach exposure. So I'm looking forward to sharing this new development with you today. I've had this Sekonic meter a while now, but have only just created a profile for it to utilize its full power. To create the profile, you need a Sekonic Exposure Profile Target 2 Mark II, and I'll make this a link in the blog post here, so if you want to go over to B&H and take a look, click on these links. You can use a number of different targets, including some of the X-Rite color targets, but I bought the Sekonic Exposure Profile Target 2, which is also made by X-Rite, but specifically for the Sekonic to create the profiles that we'll look at today. You can create multiple profiles, including ones specifically for flash and studio lighting, but today we'll walk through creating a profile with ambient light. To shoot the test target for an expansion mode profile, which I found to be the best method, it's best to wait for a heavily and evenly overcast day. You need the cloud cover to be pretty even so that the light doesn't change during your exposures, but you also need it to be really heavy overcast because you have to shoot 5 bracketed images to create the expansion mode profile, and the two extremes of these images are plus and minus 8 stops. That means if your base exposure is lower than 1/8 of a second, 8 stops below that will be longer than 30 seconds, which is fine, but it requires using bulb mode and a timer. If you use a shutter speed faster than 1/30th of a second, your 8 stop above exposure is more than an 8,000th of a second, and that is the fastest shutter speed available on most cameras. So you can't start with a shutter speed faster than 1/30th of a second. You have to set up the target so that it's level with the camera and has even light falling on it. I used a light stand and a pair of plant clamps to hold the target in place, as you can see in this photo. Once you have your camera and target in place, meter the light first with the incident meter, which is the white dome that you can see here, and either take a photo like this or note down the ISO, shutter speed and aperture settings down to that 1/10 of a stop on the aperture that you see there. It's a 0 in this image. You need to add this fraction into the software, so that 1/10 of a stop on the aperture is important. Then you switch to the reflected spot metering mode by rotating the band around the eyepiece on the right side of the meter and point the spot meter at the grey card while looking through the spot meter viewfinder and take another meter reading. Again, you need to note these settings or take a photo of them like this one. My light was at f5.6 for 1/30th of a second at ISO 160, so the same with both the incident and the reflected spot meter metering modes. I adjusted the ISO to 160 because the aperture and shutter speeds can only be selected in full stops in the software. Once you have the meter readings, with your camera in manual mode, set the same values on your camera and note where the exposure indicator is falling with the camera in spot metering mode. My camera was reading exactly the same exposure, with the caret on my meter at 0, which means that there's no need to calibrate the meter to match my camera. If there was a discrepancy here, I could change the meter in 1/10 of a stop increments to ensure that they're both on the same page, but this wasn't necessary. We then take a photograph of the grey card side of the exposure profile target 2 with the metered exposure settings and use that photograph to set a custom white balance in the camera. After you have your custom white balance set, turn the exposure profile target 2 around so that you can see the grey patch side, and check your exposure using the light meter in EV metering mode. You need to turn this metering mode on in the custom settings beforehand, and details of how to do that are in the manual. Then take an incident light reading it with the meter in all four corners of the target in EV mode. The light falling on the card cannot be any greater than 0.1 EV different across the face of the card. I have a wall behind me on my studio balcony, so I get exactly 10 EV on the top of the card and 9.9 EV at the bottom of the card, but that's within the acceptable range, so I go with this. I found that the Sekonic data transfer software that you use to create the profiles and transfer them to the meter could not handle the full-sized 50 megapixel 5D SR images. I received an error while creating the profile. Also, because you have to feed the software JPEGs, and because I didn't want Lightroom or Photoshop messing with the images, I set my camera to save small, high-quality JPEGs as well as RAW images before I started these test shots, just for the purpose of creating this profile. I left it creating RAW files as well, simply in case I forgot to turn this off again. It would not be good to get back from my next shoot to find that I only had small JPEGs. I also ensured that the picture style on my 5D SR was set to neutral before shooting my profile images. I don't want the camera messing around with the images as it creates my JPEGs from the RAW files, so neutral is a good setting for that. Once you are ready, and before the light changes, you can now shoot the 5 images to create an expanded mode profile. Start with your base settings dialed into the camera, like I say, in manual mode, and these are the values that we read with the meter earlier. My settings, as I said, were at 30th of a second at f5.6 ISO 160. Shoot the first image and then adjust your shutter speed, making it 4 stops longer. If you have your camera set to adjust the exposure in 1/3 stops, then you can just count out 12 clicks, which adjusted my shutter speed from a 30th of a second to half a second. And then shoot your second profile image. Then change the shutter speed for a further 4 stops, which took me to 8 seconds, and shoot a third profile image. Then repeat this for a 1/4 stop faster shutter speed, which from my base exposure setting took me to a 500th of a second for my 4th profile image, and a 5th and final image with a 1/8000th of a second shutter speed. As you can see in this image, with all 5 photos merged into one, the under and overexposed shots are pretty much useless exposure-wise, but this information is what the software needs to find out how much dynamic range your camera has as it creates the profile. You might also think that with the plus and minus 8 stops, images being so far under and overexposed that we don't really need to do the 5 image profile. But I tried the 3 image profile and it didn't include the entire dynamic range of the 5D SR. So I definitely recommend using the 5 image method if you pick up the newer exposure profile target 2. Note that you can get the latest software from Sekonic's website, but at the time that I created this episode, they do not officially support the Mac OS El Capitan, so that's 10.11. I was not able to connect my meter via USB with the latest version of the software that is available on their website. However, I found that by running the auto update utility in the Sekonic folder that is created when you install the DTS or data transfer software, the auto update downloaded what I suppose is an even newer version of the software, which did enable me to connect the meter and transfer the profile that I created. Hopefully this won't be a problem for long, but if you cannot connect to the meter, just try running that auto update utility. It might work for you as well. I don't know if there are similar issues with Windows, but the website does only state support for up to Windows 8. Like I say, this is as of December 2015, so Windows may be a little behind as well. When I called the Japan support team at Sekonic, they didn't seem overly enthusiastic about updating the software for the latest OS versions, for this meter at least. They said that they were updating the software for their newer meter with higher priority, although their newer meters are not as good as the L-758D, so I'm hoping that Sekonic changes this stance. Now that we have the software installed in our 5 profile photos, it's time to create the camera profile and transfer it to our light meter. Locate the JPEG images that you shot on your hard drive and make a copy of these to a new folder on your desktop or somewhere that you can easily navigate to, and then start the Sekonic data transfer software. Select the option to create new profile in the first dialog and then select advanced mode. You can pretty much ignore what it says about plus minus 10 steps, which should be stops, about advanced mode in terms of the images required if you're using the exposure profile target 2. After clicking advanced mode, you'll see the following dialog, and in there you'll need to select extended mode on the left side and then select the exposure profile target 2 if that's what you have, and click next. On the following screen, select ambient if you are also creating an ambient light profile, and click next again. The process is very similar if you're creating a profile for Flash. You'll just need to check the manual for the extra steps involved in setting up to shoot your profile images. In the following screen, select the exposure settings that you either noted down or took a photo of earlier in the process. For me, this was ISO 160, shutter speed 30, and aperture 5.6, and 0 for the 1/10 pull down. My readings were the same for both incident and reflected metering, so I added this to both of the sets of pull downs, and then click next. On the following screen, you'll be asked to point the software to the folder into which you saved your profile photo JPEGs. Once you show the software that folder, you'll see the following dialog. As long as you ensure that your image EXIF data is not stripped from the images, the software will automatically detect the exposure settings, so you can ignore the light output correction value field. Just ensure that the green checkbox is on for each image and click next. In the Analyze Data screen, click each image and ensure that the software finds the registration crosses in each image, or adjust the green plus marks as necessary, and ensure that the large green checks are all on, and then click next again. After analysing the information in your 5 profile images, you'll be presented with a graph similar to this. The 2 green vertical lines represent Sekonic's idea of where we should place our clipping points, which is where the information in our scene would start clipping, or in other words, be under or overexposed. The red vertical lines are to represent the dynamic range of our camera's sensor. Both of these values are initially way too conservative. In Ansel Adams' zone system, the dynamic range is actually from zone 1 to 9, so zones 0 and 10 are not included because they were considered too extreme to be useful. The initial dynamic range set by the Sekonic software is closer to this than what is actually useful in modern digital images. We'll talk more about the zone system in a follow-up episode, probably next week. For digital though, especially if you are exposing to the right when shooting, our useful dynamic range is much closer to the full range from full black to pure white, because there is information being recorded right up to these values that can be used if necessary. So I choose to move both of the dynamic range pointers right out to span from 0 to 255. I'd actually say that the only values that are truly useless in a well-exposed digital image are 0 and 255. So I use these values because I want to see these exact points on my light meter scale. The clipping points are more subjective and will be up to you where you want to put these, but my tests show that I can push my images very close to the digital dynamic range extremes. So I've been setting the low clipping points to 2 stops above total black and the high clipping point to 1 stop below pure white, as you can see here. If you shoot additional ISOs or flash light source profile images as well, you can add these to the profile from this dialog. But if you keep your JPEGs, you can play with that later too. So for now, click Save. And I already have a profile at ISO 100, so I'm going to call this one Canon EOS 5DS-R ISO 160, just for now. I actually found that adding multiple ISOs to the same profile leaves you with some funky settings showing up on the meter in between the 2 ISOs. So I've not loaded any multi-ISO profiles to my meter at this point. If you use single ISO profiles, the dynamic range and clipping points remain the same across all ISOs, and I think I'd rather see that as opposed to the funkiness that I was seeing. With your L-758D turned off, plug in the USB cable that comes with it, and you should then see the meter connect to the data transfer software. Select the profile or profiles that you'd like to transfer and add them to the right selected profile list, and then when you're ready, click the Transfer to Light Meter button. You can also edit your profiles from this dialog and change your clipping points, etc. You could even create both an aggressive and conservative profile from the same profile data and transfer different copies to the profile to your meter for comparison. Note that when you start editing existing profiles, the clipping and dynamic range settings are saved separately for incident and reflected meter modes. You may actually want to set these differently, and these are displayed accordingly as you switch between these modes on the light meter. But if you want them to be the same, ensure that you modify both settings in your profile before transferring it to the meter. Turn the power of the meter off before disconnecting it, but once you have your profiles loaded, you're ready to go and have some fun with your new profile loaded to the L-758D light meter. So, what's the dynamic range of my 5DS-R? Well, my ISO 100 profile shows me a total dynamic range of 11.5 stops, from -7.1 to plus 3.4 EV. And my ISO 160 profile that I just walked you through shows me 11.9 stops, from -7.4 to plus 3.5 EV. If I'd made both of these profiles under exactly the same light with exactly the same camera settings, I'd be thinking that I'd have more dynamic range at the higher ISO, and that might be the case. But DxOMark have the 5DS-R dynamic range at 12.4, larger than both of my profiles, so I'm not going to get too hung up on this. It does mean though that my current profiles, even with the dynamic range set to 0 out to 255, they are perhaps still a little bit on the conservative side, but we'll look at an example from the field and check these values in Photoshop in a follow-up episode, probably next week. Do keep in mind that I am talking about the full range of values captured when I use the term dynamic range here, not Ansel Adams' definition of the term. In the follow-up episode to this week's post, I'll talk a little bit more about the zone system and how we can analyze our scenes and images to get the most out of our cameras in the digital dynamic range. So thanks very much for listening today. If you enjoy this podcast, please share a link with your friends. And if you don't already, please subscribe in iTunes or your favorite podcast program to ensure uninterrupted delivery. You can find me on Google+, Twitter, Instagram and Facebook, and links to everything that I'm up to are at martinbaileyphotography.com, so do drop by and take a look. I'll be back next week with that follow-up episode, hopefully. In the meantime though, you take care and have a great week, whatever you're doing. Bye bye.